Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my dear students. I want to welcome you to this session of intensive 30 minutes physics learning. And my name is Teacher JB, as you know. And I want to welcome you so much because I know we are going to learn lots of new concepts together, continuing from what we were looking at last time. And my dear students of Senior 1, I want to request everyone to have a calculator, okay? Because we are going to be looking at some calculations. So you need to have a calculator, you need to have your notebook, your pen, and your pencil. And then you sit comfortably in front of your TV. Good. Now, today, we'll continue looking at Unit 6. If you remember, we introduced a brand new unit, which was Unit 6. And Unit 6 is talking about work, energy, I think it is called imbaraga, sivyo? Energy and power. I'm not so sure what power is called in Kinyarwanda, but I am sure you can find out what it is from your Kinyarwanda teachers. Now, this is our second lesson, and we are going to be looking at calculation of work done by different bodies. That's why I was telling you, you should have your calculator. Now, if you remember, last time we performed some experiments. Do you remember? There were some experiments that we performed around here, where we looked at work done when you apply a force and the point of application of the force moves. There was a trolley right here where I applied a certain force and the trolley was able to move. You remember that? We also had a force meter. That was a kind of a new word that we talked about last time. We also had a force meter. And we said a force meter is a device which is used to measure force. And if you remember very well, we had slotted masses like this. These were slotted masses. And these slotted masses were attached to, the force meter. The force meter was something like this. And inside the force meter, there is a scale. And this scale is graduated, okay? It is graduated in newtons. So you have like a 0, you have like 1, you have 2, and so on and so forth. But it is in newtons. So when you apply a force here, this is a force, then the slotted masses were able to move. And because they moved, then we said work was done, because we are moving them on a table. So we are taking this as being a table. So when you apply a force and then the slotted masses move, then the force has moved through a certain distance. And what did we say then? We said work can be done if the force moves through a certain distance. Do you remember that formula there? Work done is equal to force times distance. Again, I told you, in some books, you may find work done is given as force, then times distance, where they're using x as being distance. That is something that we looked at last time. So work is said to be done when the point of application of the force moves through a certain distance. And then also, you should remember, force is measured in newtons. What about distance? Distance is measured in, right, you have said it correctly, in meters. Just the same thing as this, Newton, and this is in meters. So the SI unit of work will then be Newton times meter. In that case, it is Newton meter. And 1 Newton meter is also the same as a joule. And so we said the SI unit of work is a joule, which is abbreviated as capital J. So that is what we looked at last time. I hope you remember that very well. And so today, our main objectives are, 1, we should define the joule. So what is a joule? Energy. or the work we do, we are saying it is measured in joules. So what is a joule? We also want to look at other alternative units of the joule. Unfortunately, in our initial interaction here, you should be able to see the alternative unit of the joule, Newton times meter. You see, we have already succeeded in fulfilling one of the objectives. Newton times a meter gives you a joule. See? And then we should also be able to use the relation W equals FD to solve numerical problems. So those are our learning objectives for today. Let's look at the screen. Now, on the screen, you have a wonderful formula. And by the way, I like students to use what we call the magic triangle. Magic triangle helps us in keeping a formula. Me, I like using it. It's very wonderful. I just want to show you how you can, insert in quantities into a magic triangle. So, a magic triangle, you just draw a triangle like this one. Does that look like a triangle on the board? This is a triangle. So I'm going to separate it here, and I'm going to separate it also there. That's how we draw our magic triangle. Now, how do we put in quantities in the magic triangle? It is very easy. So the formula is work, W equals F times D. Now, in between here, we have got a multiplication sign. This one is multiplication sign. Then this one is division. This one, division. So let us put in our values. We are saying this is multiplication. So that means we just transfer and put F there. Then we put D here. If you are not in love with D, then you can put what? X. So what about up here? What do we put? Then we are going to put W. My wonderful students of Senior 1, is that something very hard for you? I want to believe it is very easy. So know how to put these quantities in a magic what? Triangle. Maybe some people are wondering, the name is magic. Magic triangle. Okay? TR. Magic triangle. It can perform a lot of magic for you in making you to remember the formula. So work done is equal to force times what? Times distance. So from this formula also, from this magic triangle, we can get other formulas. That is, if I now want force, I will then say force is equal to, you look at where force is. Force is here. Force is equal to W. Remember I told you this one means divide by. So W divided by D. Have you seen? If I want to get D, I will say D, which is distance. Distance now is going to be equal to W, then divided by what? Divided by F. I think that is very easy. So that is how we use the magic triangle. Okay, let's move ahead. Now, how do we define the joule? How do we define the joule? Again, on the screen, as you can see, we are having definition of the joule, and I want you to read it along with me, and we try to practice it together. A joule is the work done when a force of 1 Newton moves through a distance of 1 meter. So if you have a force of 1 Newton, and then you apply that force, and the force moves through a distance of 1 meter, then the work you have done is called a what? A joule. So that's the definition of a joule. For instance, in our everyday life, if you look at that bottle of water, that bottle of water is 1 liter. And 1 liter has got 1 kilogram. Okay? 1 liter of water, 1 kilogram of water. If you raise that bottle of water through a distance of 1.5 meters, just look at what I have here. This is a meter roll. Are you able to see my meter rule? This is a meter rule, 1 meter. And so 1 meter stops here, somewhere in the stomach, on the stomach, not in the stomach, not inside. And then 50, let's look for 50 centimeters. 50 centimeters is somewhere around here. So if I add it there, so you see, 1.5 meter. Imagine I'm picking a bottle of water from the ground. I'm putting it at 1.5 meters. What do you think I want to do? I want to drink that water. So if you are of the same height like me, you know, I'm not very tall. You could be of the same height like me. Okay, so if you pick water from the ground, from the floor, and then you put it at the height of your mouth and you want to drink it, you have done work. In raising how many kilograms of water? 1. And so if it is 1 kilogram of water, it means that is 10 newtons. So if you raise it through 1.5 meters, as we see on the screen, the work done will be equal to 15 joules. So the key thing is, just imagine the magnitude of 15 joules. Raising 1 liter from the ground up to the level of my mouth, that work done is 15 joules. Do you see that? So do you think the work done in raising a bottle of water from the ground to 1.5 meters, which is 15 joules, do you think it is the same amount of work used to raise this tool up to a height of 1.5 meters? No. This is more work because it is heavier. So when the body is heavier, you then need more what? More energy. So the work done is going to be higher. Okay. Again, down there on the screen, you should be able to see the work done in raising a loaded school bag. I'm sure all of you have school bags. If you have a school bag and it is full of your books, about 6 kilograms. Now, when you raise it from the floor up to about 1.2 meters, the work done is about 72 joules. So raising 1 bottle of mineral water for 1 liter, about 15 joules. A school bag, about 72 joules. Assuming it has 6 kilograms of books, that's the mass, and you are raising it to about 1.2 meters. So that is just to give you an idea of the amount of work done in joules. Okay, let's move ahead. So a joule is related to a Newton meter. We have already said that from here. What does it mean? 1 joule is equal to 1 Newton meter. That is what it means. 1 joule is 1 Newton meter. So if I say the work done is 15 joules, okay, it also means that the work done can be expressed as 15 Newton meters, because 1 joule is 1 Newton meter. And of course, there are other ways of expressing work done, the joule, in bigger units. For instance, if I talk of 1 kilojoule, this one you must have seen it right from the very first topic, okay? Kilo, mega, giga, and so on and so forth. So 1 kilojoule, this K is a kilo. K is a kilo. So 1 kilojoule is equal to 1,000 joules, because K means 1,000. And this can also be written as 10 to the power of 3 joules. And by the way, nobody will punish you if you say this is equal to 10 to the power 3 Newton meter. Are we wrong there? I don't think we are wrong, because 1 Newton meter is the same as 1 joule. You also have megajoule. But mega, remember, it is capital M. This is megajoule. Okay, maybe I should be writing what K means. I said K is standing for kilo. M is standing for mega. Then we shall also look at G, which is standing for giga. I have a flash of 2 GB, 2 gigabytes. That's what it means. So mega means 1 million. So 1 million joules. And in terms of standard form, this becomes 10 to power 6, and that will be joules. As I told you, it is not a crime to write 10 to power 6 Newton meter. Is that a problem? No. You also can have 1 GJ. Now, G is standing for giga. And this is the same as 1 billion. This is billion. 1 billion joules. And, oh, sorry, I have missed some 3 zeros. Let me add it up. 1 billion joules. And so a billion, we are supposed to have 9 zeros. This is a billion. And so this is the same as 10 to power 9 joules, which also we said it's not a problem if you write 10 to power 9 Newton meter. No problem. So you should know how to convert those units. So kilo here, remember, the value is going to be 1,000. That is a kilo. Then mega, the value is said to be million, right? Then giga, we are saying the value is said to be a billion. Billion. Billionaire. The amount of money you have can be counted in terms of billions. Wouldn't you love to be a billionaire? It means it is this one. A millionaire. The amount of money you have is in millions of francs. I don't know how many of you are millionaires right now, but if you believe, you can be millionaires. Okay, so this is the meaning of the different units ways of expressing the joule or the Newton meter. Okay, let's move ahead. Remember our targets. Our targets, we wanted to define the joule. I believe we now know how to define the joule. The work done when a force of how many newtons? 1 newton moves through a distance of how many meters? 1 meter, like this. We also looked at work done in raising a bottle of mineral water, 1 liter of mineral water. Remember that? From the ground up to the level of my mouth, 1.5 meters. Me, I know how tall I am. So if you want to get the amount of work done, we also looked at it. We got how many joules? About 15 joules. Your school bag, raising it from the ground up to the level of your back, maybe about 1.2 meters, you do about 72 joules of work. So we have succeeded in doing that. We have also succeeded in looking at ways of expressing units of, joules in terms of K, which stands for kilojoules, M, which stands for megajoules, and G, which stands for gigajoules. And giga, remember, is 10 to power 9. Mega is 10 to power 6. Kilo is 10 to power 3. And we said kilo, that is 1,000. Mega is 1,000,000. And then giga is 1,000,000,000. Of course, there are others, but we shall not continue there. Let's look at question number 1. And I'm going to give you some time to read question number 1. Okay? Read question number 1 so we can answer it together. And remember what I've always instructed you to do. If you cannot analyze the question and list the quantities which have been given, then you have not understood the question. So let's try to analyze the question together. Okay, here we go. A weightlifter raises 2 weights of 25 kilograms each. So you can see there are 2 of them, and each one is 25 kilograms. So it means the total mass is now going to be 2 times 25, because there are 2. And so this one becomes 50 kilograms. That's the total mass. Through a height of 2 meters. So it means height, and in that case, okay, let me write height. You might feel angry. You might get annoyed that I'm using distance. Height. So let me use distance But remember, this distance is given in terms of height, and they're telling us it is 2 what? 2 meters. Calculate the work done by the weightlifter. Gravitational field strength. And gravitational field strength is given as G, and the value is 10 newtons for every kilogram. That means each kilogram is pulled by the earth using a force of how many newtons? 10. So they want us to find the work done. So that should be very easy. So what do we do to get work done? We say work done is equal to force, then times distance. And remember, our force here is going to be the weight. The weight is mg. So instead of force, then we have mg. And mg, we shall multiply this one by d. What is the total mass? It is 50 times g. G has been given as 10. Then times h, which is d, it is given as 2 meters. As you can see, each of these quantities are in their standard units, all of them. So we don't need to change anything. And so if you multiply this, 2 times 50 is 100. 100, when you multiply it by 10, we are going to come out with 1,000. And so this becomes 1,000 joules. Now, is it a problem if someone says it is 1,000 Newton meter? Is it a problem? No, because 1 Newton meter is equal to 1 joule. Is it also a problem if someone says this is, sorry, I didn't want to write 10. Is it a problem if someone says this is 1 kJ? What is K? Remember K, we talked about it. K is here. K is a kilo. And a kilo means 1,000. So it is 1,000 joules, 1 kilojoules. Same. Not a problem. So I hope you are following that very nicely, my students of Senior 1. Should be easy, not a problem. Okay, meanwhile, we are going to look at question number 2. If you have finished noting that down, then we look at question number what? Question number 2. Now, question number 2 says, find the work done. Again, as I told you, if you can't interpret the question, then you have failed. That's the first step to failing. So find the work done. According to me, they want us to find work. And work, the symbol is W. In lifting a mass of 2 kilograms, so you have a certain mass, lifting 2 kilograms. Of course, it is not this. This is not 2 kilograms. But when you lift it, of course, you know you are doing some work. So here, the mass is 2 kilograms. And see, standard unit. So far, so good. Vertically upwards through 10 meters. So what is the 10 meters? 10 meters is distance. So distance is 10 meters. So how do we find work done? Should I even do that for you, honestly? Do I need to do that for you? It's very easy. I don't need to do that for you. So here, work done is going to be force times distance, right? And what is the force? Force is going to be the weight. And remember, weight is mg. Then times distance d. This is going to be 2, and g is 10. Even if we don't give you, g is always 10. Then times d, which is also 10, because d is 10 meters. This g is acceleration due to gravity, or gravitational field strength. Okay? So if you multiply this 100 times 2, we are going to get 200. Let me test and see whether you have understood. Should I put newtons here? Should I put kilograms? Oh, you are saying no. So it means you know that we are supposed to put joules. If we don't want to use joules, we can also use newtons per meter squared. And then lastly, look at question 3. A horizontal pulling force of 60 newtons. That is your question number 3. So you have got a force of 60 newtons. is applied through a spring to a block on a frictionless table. So there's no friction on that table, causing the block to move by a distance of 3 meters. So it means the distance moved is 3 meters. Okay? In the direction of the force, find the work done. These questions are now very easy. Should even find it very comfortable. You can even do it when you have closed your eyes. Can I try that maybe? No, you have to be seeing. So work done is force times distance, which is very easy. And this is going to be the same as force, which is 60 times the distance, which is 3 meters. If it were not in meters, it would change. But fortunately, this is in meters. And if you multiply this, 6 by 3, I think you get 18. And then you add a 0. And that is going to be in joules. Isn't that true, my wonderful students of Senior 1? Small numbers, the moment you have the concept of the formula, everything becomes very easy. That's why you see I was stressing so much here, getting the formula. Once you have the formula, everything becomes very easy. So as we come to the end of this lesson, I now know, I'm very sure, you have now got the ideas of remembering the formula using the magic triangle. You remember? Using the magic triangle. So you remember the formula. You are also able to apply the formula in solving numerical questions like this. The only thing is you should make sure all the quantities are in the standard what? Unit. And also we wanted to know definition of a joule. We said a joule is the work done when a force of 1 Newton moves through a distance of 1 meter. We also wanted to know alternative units of, equivalents of joules. We said 1 joule is equal to 1 Newton meter. So I want to think that you understood that very well. And so I'm going to leave you with this question. Question number 4 is yours. A force of 75 newtons is applied to a certain body placed on a smooth horizontal surface. If 0.72 kilojoules of work is done by this force, find the distance moved by the body. Now they want us to find what? Distance. And there, the work done is given in kilojoules. So you need to know how to convert because we looked at it there. Okay? So I'm very sure you will be able to do that very well. And so the question is there on the board. And so, my dear students, I want to thank you for being attentive. And you have been taking notes. Continue revising your books, reading your books. Go to the REB website and find that book too. Read Unit 6. You are going to find so many other questions that you can practice on. Continue staying safely at home until we meet next time. Bye-bye.